a cryptocurrency analysis tool based on social metrics. Okay, so introduction. So as you can see, there is a big rise in popularity of cryptos recently, but there's a lack of accessible resources and analytical tools to do so for the general audience. And we have conducted surveys which show that there is a demand for an app that would be able to analyze cryptocurrency data to give out predictions or just to condense data for users to see. And tools currently available in the market are complementary. That is, they are either charting tools or too complex for regular users to use on just a normal basis for their investment strategies. And so we've decided to create a free to use cryptocurrency analysis and prediction platform based on social metrics. What social metrics means is looking at opinions or stats from cryptocurrency social media pages like Twitter or GitHub, or their GitHub activity, which would show in this case their developer activity, and Twitter their user base. And our goal using this app is to create an app that would give out a straightforward analysis, but also have a easy user interface for our users to enjoy the whole process. So the challenges in making these, we had three main challenges in making these out. Firstly, establishing an analytical lens. So we wanted to find a way to analyze cryptocurrencies that was unique and in some way distinguish ourselves. And after some research and some brainstorming, we decided to go for a social metrics angle, which that would mean, as I said, looking at social media data. A second problem was finding a suitable model for the data, because we use many different factors, as I will explain later, as for example, Twitter activity, GitHub activity, as well as market cap ranking, 24-hour percentage change, and more. It was really hard to find a model that would be able to give out satisfactory results like R-squared scores, accuracy. So that was a big challenge. And finally, building the application was a problem just because I wasn't really familiar with that programming language. So moving on to the solution, here is an overview of the solution. We're going to have our mobile app using Flutter Dart. We're going to start with a flash screen, and then on our home screen, we're going to be able to search for cryptocurrencies, and we're going to have a cryptocurrency list. Every time we click on a cryptocurrency in that list, we get the details such as price, market cap, all-time high, all-time low, etc. And then we have our predictions, which I will explain the factors later on. On our back end, we're using a AWS web server to serve the app and conduct ODA analysis and machine learning. We're going through a database that is on Firebase, and we're using Python to process the data through web scraping and APIs. So firstly, we have the Flutter app. So here's just the code snippet. So as I previously explained, we implemented it using Dart. And on the first version of the app, we had really just 5 important files. So firstly, we had our main file, the entry point of our program that defines all the important variables and sets up our home page. We have details page, which is specific to each cryptocurrency. And we have our crypto search delegate, which is basically our search bar. For crypto info class, it's a class to save all the cryptocurrency information, and information general is to give tutorial and guides to our users. So here was the first version of our app. We had our cryptocurrency lists with all the important stats, and then we have our information details and the analysis here. So I will go over these values later on. And as for data fetching, we did it using Python. The process was to firstly use CoinGecko API's free API services, and then using these keys, we would be able to get each cryptocurrency. We would be able to get cryptocurrency, top 500 cryptocurrencies with their respective datas, and then to find their GitHub repos, we would web scrape CoinMarketCap, and using these GitHub links, we would go on each cryptocurrency's repositories and obtain their developer activity, that is commit activity count over the last months. And after this, we're going to use Twitter's API to count the number of tweets that were used, and we're going to store all of the data in Firebase. So as for our data analysis process, we're going to start by taking the two data we just previously obtained, that is tweet count and commit count data from our database, and save them under each cryptocurrency as a percentage change versus the last 7 days. So if today the tweet activity was, let's say, 100, and in the last a week ago, the tweet change was the tweet count was actually just 80, then it would mean an increase in this case. We're going to obtain, and then using your API again, we're going to obtain 10 tweets per cryptocurrency. So for example, hashtag Bitcoin, we're going to obtain 10 tweets with that hashtag that are recent. We're going to get their polarity score from 100 to -100 using TextBot. And then we're going to calculate the retro score, which is just a really simple equation. Our retro score equals to 0.5 market view square, which we just obtained in our previous step, times the tweets change 7 days percentage, times commit change 7 days percentage, times 501 minus market cap rank, which would just show the importance of the cryptocurrency, the last part here. And we use 501 minus 500 because our app will just analyze the top 500 cryptocurrencies, and this score will always stay positive. We're going to append each cryptocurrency's price change 24, and then now we're going to move to our model, right? So for our y-axis, we're going to be using 24-hour percentage change of each cryptocurrency, and for the x-axis, what we're using is the market view score, the retro score, the market cap rank, and Twitter change. And then we're going to obtain train data for the model using scikit-learn, and we're going to first just train our model using these train data, and then we're going to fit the newly obtained data and the past data that we obtained before into our random forest regressor. So over time, we have more and more test data, and so the model will get better and better. And so using all of these data, we're going to be able to train our model, and then we're going to plug the data we just previously obtained from our scraping and APIs to obtain a prediction. And then we're going to save all of the predictions into our database, as well as the data we just used. So we're going to save model results to database. Fourth solution here is our Amazon Web Service and Flask server. That part was really easy to implement. And what we would do is that every time a request is made to our AWS server, which is through a link on port 500, the server would return each cryptocurrency's data analysis from our database as a JSON to the user. And then, through our app, and then our app would be able to convert all of that whole JSON file into data that would then be displayed to the user. And if the database is currently updating, then our server will just return refreshing data, please wait, and our app will wait for the data before display. So now for experiments, we conducted 3 experiments to see how effective our app was. So the first one was obviously to check if we solved the main problem here, that is to satisfy our investors, our user base. And so here's a quick survey we made for our testers, and the respondents indicate that retrosite can solve current investors' problems because, first of all, 80% of them agree that the UI is easy and straightforward. 80% think that accessing a cryptocurrency is pretty simple with our app. 80% agree that the analysis is easy to read and understand, and 100% of them think that overall the experience is smooth. They don't really get tangled into the app. The whole process is quick. They know what to do. They don't have to figure out anything. So this just means that we successfully solved the current investors' pains. Secondly, the experiment was for the models. As you can see, the model doesn't look really nice. I mean, the R squares don't always look really nice. But so for tests, so we just conducted different tests using our training model with different models training sizes to see which model would work best. And so for the first two tests, we used less data in our training set, and then we didn't obtain great results. And for test 3, 4, and 5, we started to add more and more training data to our models. And so we can see that on low data, our models can really pick up a pattern here. And then if you start adding more and more data, there's the random forest regression that seems to perform better with a positive R-squared score versus everything else, which doesn't really fit well. As you can see, the scores tend to go towards the negative side. And so we decided to go for the random forest regression, which was the best choice here. And these are just 5 models. We tried a lot more, but we wanted to show it through a few models. And so we can see that if we were to have smaller training data sets, then we would be better off with linear lasso and elastic knob regressions. Experiment 3 was for the accuracy of our model. So we wanted to backtest our model to see how well it would function. And so the process here is to firstly use our model to predict cryptocurrencies, each cryptocurrency, and then we're going to save that prediction into our database, which is already done through our app. Then we check back 24 hours later with the predictions we just obtained, and see how many of these predictions were actually accurate. And we found out that the accuracy of our model is to just 5 tests on different days was 92%. But the reason for that isn't because our model is really, really good in the fact that it can predict very, very precisely what's happening, but instead because our prediction is more in a range. So our model has 5 prediction ranges. It has very bearish, which would mean from negative infinity percentage to negative 15%. All of that range would represent very bearish movement. From minus 15 to 5%, that would be bearish, and then from 0 to 5%, that would be somewhat bearish, and then the opposite is true for bullish. That is positive predictions. And so because of that range of numbers, we were able to get a higher accuracy. And so the reasons was, as I said, the range, but also because we might just have the right model for our data process. So related works here include predicting the stock market using Twitter Mood, which is conducted by Johan Ballen, Huina Mao, and Xiaojun Feng. We had similarities in the fact that we both use Twitter polarity analysis, but in our case, we used more than that for our model, and they just used Twitter analysis for the entire program. And they predicted stocks instead of cryptocurrencies in their case. Crypto drivers using a wavelet coherence analysis. For this work, they also tried to find a pattern in cryptocurrency prices to try and predict them and see what kind of factors influence them. And one of the factors they included was GitHub activity here. And the third work is creating a trading algorithm using Twitter Sentiment Analysis by Stuart Kaliani, Stephanie Rosales, and Michael Signorodi. And here as well, they were using Twitter sentiment analysis, but we had a very different approach. Their algorithm was really different from ours. So for our conclusion, we have proposed an application that could help investors analyze cryptocurrencies and conduct thorough analysis of their chosen cryptocurrencies, which would be able to solve major investors' pains. And we were successful in this very goal. However, there are a lot of improvements that can make this app a lot better. Well, firstly, for our model, even though we do have a positive R-squared on our model, it's not ideal since 0.16 is still pretty low. So if we would be able to optimize our model, or maybe if we can find a better model to fit our data, we could get better satisfactory results. But the second problem would also be our API limitations, because currently we have very low API caps. As for example, that forces us to use only 10 tweets for cryptocurrency to analyze. If we had a better API, we would be able to scale that up to 100. And for GitHub, we would be able to go a lot further into their commit history and have a more thorough data analysis. And another thing that would be great would be a faster data updates. Since currently in the first version of our app, our data updates probably every hour or so. And even if we wanted to, the fastest we would be able to do would only be 15 minutes, because Twitter's API cap would stop us. If we could be able to upscale into a better API, we would be able to get faster results. And these are the elements I would wish to improve in the future. Thank you.